Before we get into actual modeling using probability distributions, let's first consider how to generate values from different probability distributions. So we'll start with uniform distribution. The uniform distribution can both be a continuous distribution as well as a discrete distribution. So we'll look at discrete distribution in just a little bit. Right now let's consider the continuous probability version of the uniform distribution. And that distribution is symmetric and it is bounded on both sides. There is a minimum value and a maximum value. And it need not necessarily be all positives, because the minimum bound, if it is a negative value, then it could very well take negative values. Okay. Now Excel has a function called RAND, and this RAND function generates random numbers uniformly between 0 and 1, 0 being the minimum bound, 1 being the maximum bound. So for example, if I type RAND and then I need to give a left and a right parenthesis, okay, this function will generate at random a number between 0 and 1 with uniform probability. Okay, and this rand function is a very key function. Because it is between 0 and 1, this value can be used as a probability. Now in Excel we have what is called auto recalculation, which is the F9 key. Okay, if you want to force a recalculation, so we can press the F9 key and that will go ahead and recalculate all the cells in the Excel spreadsheet. So when it does the recalculation, most of the times when we have deterministic values, nothing will change, so you won't see that some recalculation is actually going on in the background. But rand function is not dependent upon any input, and therefore a recalculation will result in a different number. Like right now we have 0.26988. Now if I press the F9 key, watch that number will change. Okay, now if you want a random number that is not between 0 and 1, but a different minimum value and a different maximum value, now we can use this formula to generate a random number between any minimum and a maximum value. For example, if we have a minimum value of 50 and a maximum value of 100, then we can start with the minimum value, okay, and we add a portion of the range of values, maximum minus minimum, multiplied by the rand function. So the rand function goes from 0 to 1. So if the rand is 0, then the generated number will be the minimum value. If the rand is 1, then the generated value would be 100. If it is in between, it will be one of the values in between. So this function will give you a uniform distribution value, or a random number that follows a uniform distribution between 50 and 100. Now once again, you want another replication of this, we can go and edit this cell and press enter, and that will generate a different random number, or any change that you make to any cell. For example, if I type a number 1 in the next cell, and that will force a recalculation and the number will change. And if I go and delete this number 1, that also will force a recalculation, and the random number, what we see here, will change. Now let's look at a discrete probability distribution. Suppose we have a variable that can only take these 4 possible values, and for each of them there is a probability associated with it, and of course the probabilities must sum to 1. So if you do a sum of these probabilities, you should get 1. So which covers all possible values for the variable. Okay, now we want to generate random numbers, or we want to generate value for this variable using these probabilities. Okay, so how are we going to do that? And we're going to be using a VLOOKUP function for that. And in order for us to be able to use the VLOOKUP function, we have to first set up what is called the lookup table of cumulative probabilities associated with each value. So the values here are the possible values for the distribution. So copy that. So it can be one of these four values. The cumulative probabilities, we must start with 0. So the first, because this is kind of the lower limit of the probability for each value. So 0. Then the next lower limit is you take the previous lower limit and add the probability for that value 10. So 0 through that 0.1 is the probability associated with 10. Now once we exceed this, remember this is your lower limit for a given value. Okay. Now when you copy that, so you get the lower limit of the probabilities for each of these four cases. Now when we generate a random number using the rand function, that's going to generate a value between 0 and 1. So depending upon what the value is, we will select one of these four values as the value of the input cell following this distribution. So for example, if the rand function gives you a value, say 0.05, so 0.05 is in this interval, so the value of 10 will be chosen as the value for the input variable. And if the rand function gives you, say, 0.6, so 0.6 is a value between these two, so 20 will be chosen as the value for the input variable following this distribution. And if the rand function gives you a value, say 0.95, 0.95 is greater than 0.8, so 25 will be chosen as the value for the input cell. Okay, so let's set this up. So we have VLOOKUP. Okay, so the first value is the lookup value, and that's our probability, which is the rand function. Next is that's our lookup table. Then we want the random value to come from the second column, so we put 2 there, and that will give you the value for the input variable that follows this discrete distribution. So this formula will generate random values using this probability distribution, this discrete probability distribution. So this is how you will generate discrete probability distribution values. Next, let's look at a uniform distribution that must be discrete. In other words, we have a minimum value and a maximum value for the uniform distribution, but we are not allowing all possible values within these two limits, but only integer values. So if that is the case, you can use a function in Excel called rand between the minimum value and the maximum value. So that will give you only integer values from this interval. So it's a very, very easy function. So you don't have to even use the rand function here. The rand between will automatically generate a random number and then adjust for the fact that we have a minimum and a maximum value, and it will give you integer answers between the minimum and the maximum. Suppose if you want to allow all possible values, like in a continuous distribution, then you have to use the distribution that we already discussed in the first sheet of this file. But this one, remember, rand between is a discrete uniform distribution. It will only give you the integer values. Okay, so let me click the delete key, and that will force a recalc. So see, you get 1. Okay, press the delete key again, you get another random value. Okay, but integer within this interval. Now let's go to the next tab that gives us normal distribution. Okay, normal distribution. Okay, we know what it is. So we need 2 values to generate random values from the normal distribution, and that is the mean and the standard deviation. So given the mean is 100 and standard deviation of 10, okay, it can be any value, but suppose if the mean is 100 and standard deviation is 10, then we can use this function called norm dot inv. Okay, the dot is missing there, so there should be a dot. Norm dot inv. Okay, so the first input is rand, so that gives you the probability, and then mean and standard deviation. This will give us values from normal distribution with that as the mean and that as the standard deviation. Okay. Now suppose you want integer values only from the normal distribution. Then, so we have the norm.inv, right? So before we do the norm.inv, we have to use the round function. So we nest the norm.inv function within a round function. That will give you, okay, so that is rand, mean and standard deviation. Okay, so that will take care of the continuous normal distribution part. And for round, you have to specify how many decimal places to round, and we want integer values, so round to 0 decimal places. Now that will give us an integer value from this normal distribution.